Today we're going to work on solving quadratics ax squared plus bx plus c when a, that means the number in front of x squared, is 1. This is section 8.6 in your book. And I want to begin by doing a warm-up problem. And let's say that I have x plus 3 times x plus 7. And I told you to multiply those two binomials using FOIL, which we have worked on. So using FOIL, x times x is x squared. The outside terms, positive times a positive, I get plus 7x. Inside terms, I get plus 3x. Last terms, when I multiply them, I get plus 21. And I combine my two middle terms, and I get x squared plus 10x plus 21. What we're going to do today is we're going to be given a quadratic like this one, and to solve it we're going to need to be able to go backwards into these two binomials. So let's get right to it and do some examples. It's not as hard as you think. If you've been doing the practice on FOIL, this should be pretty easy. So the first thing they're going to ask you to do tonight is they're going to give you a quadratic like x squared plus 9x plus 20, and they're going to ask you to factor it. And when we say factor, I'm going to want two binomials. Alright? And what we're doing, like I said here, is we're doing FOIL backwards. So if you look at this x squared term, I always get it from an x times an x. So when the a term is 1, this is super easy. I can go ahead and put x and x in here. So now what I need to do is find out what numbers do I put here and here that multiply to get 20. Now, I know you probably already have figured out what those two numbers are, but I want to show you a little chart you can make that will help you organize and think through this. Let's think of the factors of 20. I could do 1 and 20, but 1 plus 20 makes 21. I could do 2 times 10, so 2 and 10 are factors, but 2 plus 10 is 12. And I could do 4 times 5. And 4 plus 5 is 9. And that is the winning combination because it gives me my middle term. So, to finish factoring this thing, it's x plus 4 times x plus 5. And you could check this mentally with FOIL. X times x is x squared. Outside terms plus 5x, inside terms plus 4x, last terms I get 20. Let's do another one. Let's say that we had x squared minus 8x plus 12. Well, we know we're going to have two binomials. We know we're going to have an x and an x. But we need to make a little chart here to come up, think about our factors of positive 12. So obviously 6 and 2, 6 times 2 is 12, but 6 plus 2 is positive 8. That doesn't work because I need my middle term to be a negative 8. So how about negative 6 and negative 2? Negative 6 times negative 2 makes positive 12. Negative 6 plus negative 2 is negative 8. So I need this to be minus 6 and minus 2. Okay. Keep going here. Try to show you as many quick examples as I can. Let's say that we have x squared plus 2x minus 15. Once again, I am going backwards with FOIL, so I need two binomials with x's. But now, when I think of my factors, I want these two things to multiply to get a negative 15. So if I do positive 5, I don't want positive 3, I want negative 3. 5 times negative 3 makes negative 15. And 5 plus negative 3 makes 2. So there's my winning combination, x plus 5, x minus 3. Alright, the next example, number 4. 18 minus 7x plus x squared. You're going to see some problems written this way, and that's why I wanted to show it to you. You're probably noticing that this thing is out of order, so just rewrite it in order. Positive x squared minus 7x, and since this 18 is positive, I put plus 18. And then we just move through and factor it like we have been. I'm looking for the factors of positive 18, and I want a sum of negative 7. So if I do negative 6 and negative 3, hold on just a minute, I noticed something on this problem. This should have been a negative 18 over here, which would make, I wrote the original problem down incorrectly, sorry about that, but it still works out the same way. So I'm looking for factors to get negative 18. Negative 6 and positive 3, well, negative 6 and positive 3 add up to be negative 3. That doesn't work. How about if I did 9 and 2? How about positive 9, negative 2? That multiplies to be negative 18, but they add up to be positive 7. So flip your signs around. How about negative 9 and positive 2? That works. So this thing factors into x minus 9, x plus 2. Now, the only thing that changes when they tell you to solve an equation, all right, and that's the second half of this section, is when they tell you to solve, and let's say they give you something like r squared minus 2r minus 24 equals 0. You do everything the same. I want to get this into two binomials, but it'll be equal to 0. I know that's going to be r and r. I make my little factor sum table to find two things that multiply to get negative 24, but add up to be negative 2. So let's say that I had negative 8 and positive 3. Well, those add up to be negative 5. That doesn't work. So how about negative 6 and positive 4? Those multiply to get negative 24, and they add up to be negative 2. There we go. So this is r minus 6 and r plus 4. Notice we just did it exactly the same way we did the last few problems. But to solve this, it's really easy. Once you get it into this form, there's a property called the zero product property that says if I have something times something equals 0, I can set each of these somethings equal to 0 and solve them separately. It's called the zero product property. And that property means once I get this quadratic factored into these two binomials, all I got to do is set the binomial equal to 0 and solve it. So it's very simple algebra. R equals 6, subtract 4, r equals negative 4. Alright? And the only other thing that I want to mention to you on these solving problems is that they may write them a little bit differently. Like on this second one, x squared plus 6x equals 27. Well, if you notice, this is written differently than the first problem. The first problem was written equal to 0. Well, I can do a simple algebra step to fix this. I can subtract 27 from both sides so that I have x squared plus 6x minus 27 equals 0. And then I can proceed to factor it the same way, x and x. Find my factors and sum. I need two things that multiply to be negative 27, but combine to be 6. How about positive 9 and negative 3? 9 plus negative 3 is 6. That works. So it's x plus 9, x minus 3. Using the zero product property, I split these up. I said x plus 9 equal to 0. I said x minus 3 equal to 0, and I solved them both. So one solution is 3. The other solution is negative 9. Notice there are two solutions. With a quadratic, that's always a possibility. And we're going to talk later about what these two solutions mean graphically. And we will stop there for today.